Today on How It's Made. Tasers. That's a neuromuscular incapacitator to you and me. Canned soup. No joke, it's a super report. Jaw harps and mouth bows. It's the homemade on How It's Made. And diving boards. We hope to make a big splash with this one. A leap into the known. But first... A taser device fires bursts of electricity to deliver a high-voltage, low-amperage shock that temporarily disables the subject. Invented in 1969 by an American aerospace scientist, the taser has become a weapon of choice for police forces around the world. Today, when a police officer reaches for a weapon, it's often one without bullets. From a cartridge on the front, the taser fires electrified darts, which on impact cause muscle contractions in the target subject. The subject is immobilized, but usually recovers in a few minutes. This metal capsule contains the propellant, pressurized gas. A robotic arm inserts the capsule in a plastic chamber. The next robot places a part called the primer disc on the capsule. It contains the chemicals to generate a mini explosion that will drive pins into the capsule, releasing the gas. A protective screen is then added. That's the primer disc on the left and the screen on the right. They punch out a round piece of foam, and the robot thrusts it into the chamber and tamps it down. After welding it in place with ultrasonic vibrations, the robotic arm flips the unit up and into a second plastic chamber. The placement leaves just enough space between the inner and outer chambers for wire bundles to be inserted later. Another robot tucks the assembly into the plastic cartridge. It has slots for other components like insulated copper wire bundles. A machine winds the wire in a tight figure-of-8 formation. This wire will electrify the darts as they're deployed, and the figure-of-8 winding reduces the possibility of tangling. A worker places 2 bundles in the designated spaces in the cartridge. He tops each bundle with a piece of strong polyester film, and this keeps the wire pack from springing apart as he slides it off the fork and presses it into the cartridge. He's now ready for the barbed taser darts. He threads the end of each wire bundle through one and knots it. He installs the darts in the cartridge, using a special tool to seat them correctly. He selects plastic wedges, one for each wire, and wraps the other end of the wires around it. He attaches electrodes to allow the flow of electricity to the cartridge. The next part is called the blast door. It will break in two as the taser darts are deployed. The robot snaps it in place on top of the cartridge. The door is color-coded to signify the range of the darts. Yellow signifies 4.5 meters in this case. With the compressed air cartridge complete, they now focus on the taser's deployment mechanisms. A technician installs a laser system and 2 LED lights in the plastic casing. The laser is an aid for aiming, and the lights will illuminate the target. He adjusts the laser's aim to sync it with one of the darts, using a bullseye target for alignment. Next, they immerse the high-voltage board in epoxy resin and pump more directly into it. This board is the part of the taser gun that generates electrical pulses when the gun is in stun mode. Once cured, the epoxy encapsulates this unit to insulate the components. He then inserts the high-voltage board in the gun casing, along with the controller board, the brains of the taser, and also installs an information display board, then makes the necessary connections. He plugs the assembly into a power source and tests the laser and LED lights. He snaps on the trigger and confirms that it makes contact with the plunger on the control board. He then joins the other half of the taser casing to the one with all the working parts. Then an ultrasonic welder fuses the casing parts at the tongue and groove seams. Protecting the outer casing with a sheet of plastic, the technician welds a safety switch to the trigger. This critical part will prevent accidental firing. In a test chamber now, they activate the taser without the air cartridge. Without the cartridge, the taser works as a handheld stun gun to zap the target directly. Once it meets the tester's approval, this taser is ready for deployment. A consumer model is also produced, and like the police version, will deliver the same stunning results, though hopefully you'll never experience those. Soup is as old as cooking itself. Its appeal is detailed in the Old Testament, where Jacob trades an inheritance for a simple pot of lentil soup. Today you don't have to sacrifice anything for a bowl of soup. Well, perhaps just the money to buy a tin opener, which is always handy. With With the invention of canning in the early 19th century, soup soon became available on demand. No need for a long cook, just open the can and reheat the contents. To manufacture lentil soup, they first make a soup base. They load measured amounts into a heated mixer, beginning with pureed garlic. The mixer's walls are steam jacketed, so the mix will cook evenly with no scorching on the bottom. The next ingredient is olive oil. They activate the steam heat and the garlic begins to sizzle. They add chopped onion. The mixing blades gently toss the ingredients as they gently fry. They blend in diced celery and cook until translucent. The next ingredients take the flavour up a level. They include chopped carrots, sea salt and spices. Balsamic vinegar adds a sweet tartness to this lentil soup base. They open a tap and filtered water pours in. As the soup begins to simmer, they add crushed and diced tomatoes. The final ingredient for this robust lentil soup base is spinach. Mixing it makes for an enticing colour, and as the ingredients cook, they become increasingly aromatic. Meanwhile, raw peeled potatoes are on their way to a hopper. The slats prevent the potatoes from rolling back as they make the climb. From the hopper, the potatoes slide down a chute and into a revolving drum with cross-cutting blades. The blades cut them into small cubes and spit them out. After passing a metal detector, the potato cubes land in a bin. In small cube form, they'll cook quicker. Next, lentils hard and dried surge in a steady stream onto a revolving table. The table has openings that lead to little chutes with doors. They open to funnel the lentils into cans, moving on a conveyor below. This ensures that a specific amount is fed into the cans. Partially cooked green beans and the raw potato cubes now flow onto a second revolving table. The cans with the lentils have now moved into position below. The vegetables fall through the holes and into the cans. The cans with mostly uncooked ingredients now head towards a piston filler. It pipes the steaming hot vegetable soup base directly from the kettle mixer into the cans. In the hot liquid, the lentils, potatoes and green beans at the base of the can cook a little and soften up. Sensors detect the approach of the cans and cue up the lids. The lids drop one by one onto the cans below. A device then interlocks the rims of the cans and the lids for a hermetic seal. The cans move into another lane, then travel past an X-ray machine. It scans the soup inside for metal contaminants, like stray bolts or screws. If the images are clear, the cans of soup move on to a giant pressure cooker. Here the contents cook for about half an hour. Pressure cooking simulates the effect of a long simmer in a fraction of the time. The soup then cools for 10 minutes. It's now thoroughly cooked and preserved. Now on their sides with glue applied, the cans of lentil soup get their labels. They produce over 15,000 cans of lentil soup an hour at this factory. That's 105,000 cans in one shift. Now that is what I call soup on a biblical scale. Coming up, we pool our efforts and dive into a factory where they make springboards. Not only that, we're going to change the whole tone of the show and see how jaw harps and mouth bows are made. Very rock and roll. See you after the break. The jaw harp and the mouth bow are among the earliest musical instruments. A Chinese drawing from the 4th century BC is believed to be the first record of a musician playing a jaw harp. And cave paintings in southern France from 15,000 BC depict someone playing a mouth bow. Well, they do say the old tunes are the best. The mouth bow is a stick of wood with a single string that the musician plucks or strums whilst altering the vibration-generated sound by mouth. The jaw harp is a metal instrument. The musician plucks its flexible tongue to produce a twanging sound, which he then modulates with mouth positions and breathing. This craftsman makes the jaw harp's frame out of a 3mm thick square steel rod. He measures and marks the required length and bend points, and cuts the length with a standard hacksaw. He clamps the rod in a vise, then slips metal pipes over the ends to prevent them from twisting, as he bends them to form the arms of the frame. He aligns the arms, leaving just enough space between them to allow the tongue to vibrate without obstruction. For the instrument to produce quality sound, the arms must be perfectly parallel to each other, their edges in mirror image. He marks the tongue's position in between the arms and files down the metal within the markings. This creates a notch in which the tongue will sit. The tongue is made of spring steel, a type of steel which, when bent, resumes its original shape. Before attaching it, he saws a tiny undercut in each side of the notch. Then he inserts the tongue and hammers the undercut sides to compress them over the tongue and lock it in position. He heats the tip of the tongue, and once the metal softens enough to bend, he angles the tip to form what's called the trigger. Then he heats the end of the trigger and bends it into a loop. This is what the musician's finger strikes to make the tongue vibrate. Finally, he files the tongue's edges sharp, a last detail to improve the instrument's sound quality. To make a mouth bow, the first step is to find a stick that's between roughly 1/2 metre and 2 metres long, not too heavy, and ideally with a T-shape at the end. In his workshop, he trims it to the required length, and using a rasp, files the knots flat. He files the top end until it's about 5mm thick. This forms the mouthpiece, which you hold gently to your lips while plucking the string. The string vibrates the mouthpiece, producing sounds which you alter by changing the shape of your mouth. He drills a hole towards the base of the mouthpiece for the string. Then just below that, files a notch for the bridge that supports the string. Just below the notch, he hammers in a steel nail, called the pin. He drills a 6mm wide hole at the T-shaped end of the stick. This is where he'll insert the tuning peg, which he constructs out of a wood knob and dowel. He makes the string from a length of piano wire. He forms a loop at one end by twisting it with pliers around an awl. He feeds this end through the hole at the base of the mouthpiece. He hooks the loop onto the pin. Then he threads the other end of the string through a hole in the shaft of the tuning peg at the bottom of the stick. He turns it to tighten the string. Just as on a violin or guitar, the tauter the string, the higher the note it produces. The final step is to position the bridge under the 10th string. By elevating the string, the bridge prevents it from cutting into the stick. Who would have thought that a piece of wood and a piece of string would be able to deliver a concert piece? Or for that matter, some old bent steel. Mind you, it's not exactly heavy metal, but let's not harp on about that. The earliest known reference to a diving board appears in a hieroglyph from 480 BC. It depicts a man plunging headfirst into a pool of water from a platform. Today, diving boards are standard equipment at larger public pools, allowing you to make a splash at your local baths. One end of the diving board is fixed to give the other end the bounce required for a big splash or a graceful swan dive. To make the diving board's shell, workers load a sheet of acrylic into a clamping machine, which transports it into an oven. The oven heats the sheet for about 30 seconds to soften it. Then a forming machine applies suction to draw the softened acrylic tightly over a mould in the shape of 2 diving boards. Fans blow cool air, hardening the acrylic to this shape within seconds. They extract the moulded acrylic, then saw it in half to separate the 2 diving board shells. They coat the shell surface in a resin and fiberglass mixture. This tool is called a chopper gun because it chops and shreds the fiberglass string, then shoots it out drenched in resin. They roll it to compress the fibers and push out air pockets. Any trapped air would create a weak spot in the diving board. After letting the resin dry and harden for 30 minutes, they begin filling the shell cavity with half-centimetre thick fiberglass mat. They drench the mat in resin, rolling it all over to ensure every millimetre gets saturated. Then they lay down another fiberglass mat, this one a bit thinner, and soak it with the existing resin. The diving board's core is made of laminated wood, which is several thin layers of wood glued together. Laminated wood is stronger than a solid piece of wood. After rounding the top edge, they lay 2 wood laminate cores over the resin-saturated fiberglass mats. They position clamps to hold the cores in place. But before tightening, they insert metal spacers to ensure the cores are correctly positioned within the shell. Once the positioning is perfect, they tighten the clamps and let the resin cure at room temperature for half an hour or so. Then the clamps are off, and workers cover the cores with an even thicker fiberglass mat, impregnated with resin. This is the bottom of the diving board. They make sure the mat is centred. Then manually form it to the shape of the board, pushing out air pockets as they go. They spray on some decorative paint, then put the board in an oven for 24 hours to cure. When it comes out, they use a diamond blade saw to cut off the excess fiberglass around the edge. Then they do a final trimming to make the edge neat and smooth. They mask the sides with tape, leaving only the top exposed. This is where they'll now apply a rough texture, a safe, non-slip surface. First, they roll on a thin coat of resin. Onto that, they sprinkle a layer of silica sand, making sure to cover the surface thoroughly and evenly. The sand sticks to the resin, which sets and cures in about 15 minutes. After sweeping off the excess sand that didn't adhere, they roll on a coat of laminating resin, which bonds to the sand, giving the surface a clean, finished look. They pull off the tape and apply the manufacturer's label to the side. The diving board is now all set to be installed on a stand at the deep end, ready for anyone to take the plunge. Just remember, no running, bombing, or heavy petting.